We be recording.
Then myself again. Yeah. The IBM 1620 cadet for CAD doesn't even try.
We're going to start the actual meeting. So if you're not the presenter, Bill, you should be muted at this time, except for me, because I've still got my finger on the space button until the end of this sentence. Over.
Hey, Bill, do I have the power to record?
Bill is recording at this time.
I got the recording going. You want me to start talking now, or was that the beginning, or what? What are we doing? Kevin's muted.
It's the beginning, and it's your turn to talk.
Very good. All right. My talk was scheduled for 20 to 30 minutes, and it'll probably run more like 18. And so that gives me the opportunity to do some enrichment for this meeting. And it also means we'll have a 3-minute set of entertainment, which will allow time for more people to come in and straggle. In fact, it reminds me of a fellow I worked with who always insisted meetings start exactly on time. So 10 o'clock meeting would start exactly at 10 o'clock, and then they would call for a 10-minute recess while all the people straggled in. So we will now go to our little enrichment.
Pat, welcome, and please mute.
Any deck you want. It makes no difference which one, a deck of your choice. I want you to open them up, remove the jokers, and give the cards a thorough shuffle. While he's doing that, let me tell you, the people that witnessed the Scarney Ace trick were dangerous criminals, such as the notorious Arnold Rothstein, who was even accused of fixing the World Series of 1919. George McManus, another gangster and card hustler, was also present. Now, McManus was the card mechanic. He was a true-to-life card cheat. He could do literally anything with a deck of cards. These were the types of men that wanted to see if Scarney could cut to the aces, not with his deck, but with their own shuffled cards. Okay, now the cards are shuffled. Now I want you to notice this is the first time that I am touching this deck. Okay, I have not touched them earlier. What you're about to witness is something that puzzled even the best magicians to this day. I now attempt to recreate the legendary Scarney Aces. Scarney would start off by giving the cards a shuffle like this. Then he would cut to an ace. That's the first one, the ace of clubs. Thank you. Now, some people may think that I'm somehow able to see the cards, so would you do me a favor? Please come behind me, and what I want you to do is cover up my eyes with your hands. Okay. Wow, this feels good. John Scarney, eat your heart out. This time I'll give the cards a few shuffles while my eyes are shut, and I will try to cut to the second ace. Hopefully, if I'm right, it should be right about here. Thank you. Thank God for that one. Now, the game was called Cutting for High Card. Because this is television, we can't play for real money. But if I do cut to an ace and you want to give me a couple $100, it's up to you, okay? Let's have some fun. Would you cut the cards, please? Okay, and let's see what you cut to. You cut to a queen of hearts. That's very good. Now, that was good, but it really wouldn't have mattered what card she cut to, because Scarney would always cut to an ace. Thank you. Now, Scarney knew that it was only a matter of time before these gangsters would want to know the secret. Here's what he told them. He said that during his shuffles, he was able to actually see the ace in the deck, and not only that, but count how many cards down it was. This is what magicians say was impossible. But I'm going to tell you with 100% accuracy that the last ace is exactly 12 cards from the top. Not only that, but I'm going to cut exactly 11 cards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 cards, and the 12th card, the ace of diamonds. Thank you. Yes.
Oh, you're back home. It turns out I'm this magician named John Scarney from the 20s and 30s and 40s. I am the John Scarney resource person. He's been a kind of a study of mine. I do a 2-hour presentation on his story. So this was a little piece of it. The trivia is that John Scarney was the hands for Paul Newman in the movie The Sting. So into our program.
Hey, how did he do it?
Well, as a magician, I have all kinds of snippy answers about it, but we won't go into that. In fact, I'll tell you. I'll tell you some embellishment. You know, I'm a member of the Magic Castle in Los Angeles, which is a private magicians club with 5,000 members. And I was there one time, and Bill Malone, who just gave this presentation, was in the room. And I went to him and asked permission that I could use that clip in my presentation. And he said, certainly. And he said, Bill, he said, you have a minute? He said, I'll be glad to tell you how I actually did that. And first it went through my mind of saying, no, I'd rather not know. He said it's so straightforward. He said, let me tell you how I did it. And I thought to myself, no, I would rather really not know to keep the mystique and the interest alive. And about that time he was interrupted and said, oh, I have to leave. He said, I'll tell you next time I see you. And there never was a next time. So that was that. Anyway, hooray for Bill Malone. Let's see, let me share screen.
Bill, are you going to record your talk?
Yeah, we're recording right now, whole thing.
Okay.
Okay, now before I get started, I'll remind you, please click on the Zoom speaker view if you haven't already. These slides are very detailed. Normally in a talk, large building talk, we wouldn't use slides these detailed because they have a lot of small words, but since we're all near a computer screen, it'll work. So, just in case, you probably already know, but I'm Bill Ragsdale, the co-founder of the Fourth Interest Group in 1978. This presentation is Exploring the Wonders of D-Charting here at the Silicon Valley Fourth Interest Group, August 22nd, 2020. Today I'll start with a bit of programming history. We'll talk about traditional flowcharting, D-chart symbols, D-chart structures, comparing traditional and D-charting and fourth structures, and some actual programming examples. The biblical book of Revelations uses the 4 horsemen of the apocalypse. From left to right, they are death, famine, war, and conquest. This brings to mind the 3 horsemen of structured programming. They are Edsger Dijkstra, who coined the phrase structured programming and received the Turing Award in 1972 and did a lot more. Nicholas Wirth, he was the designer of Algol and Pascal and received the Turing Award in 1984, and he was very proficient or prolific also. Finally, Tony Hoare, who created Quicksort and also received the Turing Award in 1970. The 3 of them, Dijkstra, Hoare, and Dahl, wrote the influential book, Structured Programming. Programming has gone from binary switches to assembly language, to line-oriented programs such as BASIC, and to a wide variety of high-level languages. These 3 men were effective advocates for structured programming, which used linear flow, control structures, and program layering. In particular, there was no unstructured branching, the infamous GoTo. Dijkstra submitted a letter to the CACM, a case against the GoTo statement. It was retitled by the editor of that journal, Nicholas Wirth, which became GoTo statement considered harmful. That phrase, considered harmful, entered the programming lexicon and has been applied to many situations since then. Fortunately, Fourth was born structured, layered, with single entry and exit points, and of course, no GoTo. Today, we're going to examine one of Dijkstra's lesser-known contributions, D charts. Fortunately, FIG co-founder Tim Harris memorialized D charts in Fourth Dimensions, Volume 1, Number 3, which my wife Ann typed on a Selectric typewriter 41 years ago. I'm sure you all remember typewriters. I strongly suggest you take notes. While the concepts are simple, you should capture them as we go. You probably don't have a fresh copy of Fourth Dimensions Volume 1, Number 3 at hand. I've used D charts in my every programming effort over 40 years with or without Fourth. Thank you, Kim Harris and Esker Dijkstra. And now on to the serious material. At the left, we see the historic and still used flowcharting symbols. Just check for them in Microsoft Word or Publisher. We find 6 symbols and conventions for connecting them by lines. No structure was imposed there. It was the wild woolly west. At the right, we see the 5 D chart symbols. The vertical line means a sequence of actions. A branch or fork marks the unconditional branch, the if statement. The circle means an n-way branch, a case statement. A circle with an X is the branching origin and usually the exit point for a loop. Remember, the beginning and the end of a loop. Finally, a solid circle marks the return point of a looping structure. That is, the loop is implied to return to its corresponding switch point. That's it. No boxes, no templates needed, quick to draw and redraw. The application of these symbols is quite straightforward. Here are the 4 rules. You show sequential statements vertically. Lines show control paths. All lines go downward or to the side. That is very important. All lines go downward or to the side. In classical flowcharting, the return paths go upward, and you have a combination of upward and downward paths at the same time. And, oh, that's it. That's the 4 rules. Perfect. So here's some quick examples. Many more will follow. Don't worry if you miss them, you'll see them again. The if conditional branch begins with a test at the upper branch or fork. The true portion progresses one way, usually to the right. The false part is optional to the other direction. If the false part is missing, the flow just goes directly downward. Now an example of a loop, which has several variations. The switch, that little circle with an X, marks the start and return point of a looping structure. Solid circle denotes the loop end and a return to the switch point. Upon concluding the loop at the switch point, execution continues straight downward. Now, a variety of tests and branches may be done, and we'll see several. Here's the familiar begin until. This is a conditional looping test. The loop repeats until the exit condition exists at the bottom. The loop structure of the loop structure at the solid circle. Then flow returns to the main vertical path. Again, loop conditions set it up. The switch point is encountered. The looping action is done. The until is at the end, and then flow goes to the continues on linearly. Here's an example of the case statement. It begins with an n-way test and an open at the open circle. The diagonal lines lead to the possible execution code. All those choices return to a common vertical flow path. Again, all lines go downward. Here's a one-way logical test. We're now going to compare the traditional flow chart with D charts side by side. Traditional on the left, flow charts, D charts on the right. The purpose is to convince you that D charts are simpler and more expressive. We see the one-way branch. In the true case, code branches to the right with nothing on the other path. This is our if-then format. The two-way logical test. In classical terms, at the left, we see if, then the test, the true execution part, the else, the false execution, and ending with an end if. The D chart equivalent on the right depends on the branch and labeling to indicate the details. In fourth, we have a leading test, the if, then the true execution portion, else, the false execution portion, and the then to end the structure. Now, the infinite loop. The infinite loop begins with a switch. That's the origin and the return point, followed by actions, ending with the solid circle return point. There are no exits. The infinite loop. This might be an operating system that runs perpetually, or remember the song, on a clear disk, you can seek forever. The indefinite loop. The indefinite loop returns to the switch point until concluding condition is met. Then the execution continues downward. So at the beginning, we have a test condition, true actions on the side, ending in the loop. There are some conditions set up on that limit that determine the endpoint for the looping structure. Now the finite loop. In the finite loop, initial loop values or limits specify the number of executions. Again, the loop begins and ends at the switch point until those number of execution loops have been executed. So we've seen a brief introduction to D charts. We'll see some more examples. Right now, though, I'd like to review the pros and cons. First, the pros. First, D charts have more information per page. The symbols are more compact, less boxes, less space taken. They're quick to draw for rapid revision. They're simple, hand-drawn with paper and pencil. No need for rulers, no need for templates. You don't need a template. Equipment is really simple. It's a piece of paper and a pencil. And finally, they are context-free, so they'll fit any computer language. Now the cons. D charts will confuse those unfamiliar and require extended explanation. It's just like programming in Forth. When you try to demonstrate a program written in Forth to someone else, you've got to give them a lot of background on how Forth works. The same way with D charts. Secondly, they're not really suitable for publication because of the same confusion factor. I searched the internet valiantly and could not find any reference to D charts. I suppose they occurred in a book by Dijkstra and have not been picked up anywhere else. So let's look at some code fragments. We're going to tie D charts to Forth. Here's our first example, which is a two-way logical test. This is our familiar if, else, then. On the left is the actual Forth code. We see a test, the if, followed by the true action, the else, followed by the false action, concluding with then. As an aside, this form drives non-Forth programmers crazy, as it is inconsistent with their other language experience. When they see the then at the end, that really gets them. Anyway, at the right appears our now familiar two-way test D chart. Test, true action on the right, false on the left, returning to then. Now we see the indefinite loop we mentioned a moment ago. This indefinite loop in Forth is simply begin, do actions, and then repeat it again. Begin, action again, begin, action again. The D chart has the switch and return point. There's no need for any code below the switch point as execution will never reach it. This would be the outermost loop in an operating system. In Forth, it's the classical quit outer interpreter word that interprets input into text and numbers and does execution. The only exit in this case would be in case of a gross error or a reboot. Now the definite loop, which to us has the form of limits, do, actions, ending in loop, which returns to do. This is our do loop structure. D chart simply has a switch point specified by the looping parameters and the dark circle return point. This structure would typically be used to print a fixed length text stream. The indefinite loop. In Forth, the indefinite loop is begin while repeat. Begin marks the switch point. Stack parameters control while, which either selects the looping action or returns to the linear execution at the switch point marked by begin. Here's another version of the indefinite loop. In this case, the test is at the end. Here's the form as begin until. Begin marks the loop's unconditional start. Looping continues until the conditional test at the concluding until is true. Execution returns just after the initial begin, straight down to the bottom to that final action. Now we're going to see three real-life examples. First is an absolute value conversion, and then string formatting, and then finally some 2's complement math. This is the high-level definition of ABS, ABS, the absolute value fourth word. It's often written in machine code with the same structure. At the left, we see dupe 0 less than, test the input value. If it's less than 0, it's replaced by its 2's complement by negate. Otherwise, the original value remains. Similarly, it's expressed on the D chart at the right. Here's a code fragment to convert a stack number into a text string in a text buffer. The format we want is hundreds, tens, units, decimal point, tenths, hundreds, thousands. At the left, we see 3-0 do, which sets up the loop for 3 passes. 10/mod append develops the quotient, appends it, and yields the dividend for the next pass. 46C comma appends the ASCII decimal point to the string. Then the second loop repeats for the 3 decimal digit portion. Finally, at the very end, drop removes the remaining dividend. I suppose nested loops could be used, but it's some loss of clarity. Now we see 2's complement arithmetic. The classical flowchart is on the left, which I picked for its complexity. And we have the D chart on the right. Both are covering 2's complement arithmetic. Frankly, I didn't try to decipher the operation of the flowchart on the left. It was easy to duplicate its control flow on the D chart, though, for its informational value. So now we're going to have a real-life example. This will be, in some detail, a program that I wrote a few weeks ago. It prepares a printed report from a selectable number of rows and data fields in a ported file. It's from my son's company. From Shopify, they export a weekly CSV file. There's all their product sales. And my job was to compress this all into a report format and do some extraction and generate another CSV file. So the 4 lines at the left summarize the entire function as a D chart. First, there's the input of the CSV file, set up the control parameters, convert all the rows, and display them. Again, the entire concept of the program done in 4 lines. So how do we convert all the rows for output? We add a loop, noted by the blue arrow. The switch and dark, we add a loop, noted by the blue arrow. It has the switch and the dark circle. Now I'll read the program from the top down. Input the CSV file, set up control parameters, loop over all rows, converting each one and printing it. But that raises the question, how do we convert all the fields in one row? Aha, we add another loop. The loop is specified to do just that, convert field by field across the row. The program now reads, input the CSV file, set up the control parameters over all the rows, over all the fields within a row, convert all fields until they're processed, display, and repeat for the next row. Properly written, you should be able to read a D chart and get the full logic and action of the program. But the fields contain text, which should be left justified, and numbers, which should be right justified. So how do we handle this? Here's a hint, we have to make a decision. So we add a two-way test with appropriate actions for text and numbers. Again, text would be left justified, number would be right justified. And now we see this translated in the shell of fourth code. I'll read the fourth code. This word reads, define the word report, read the input file, set up its parameters, begin. While we have another row, begin. While we have another field, if the field is a number, format it as right justified, else format the text as less justified, then loop to the next field in the row and repeat until the row ends, display the formatted row and repeat for any remaining rows. Finally, we end the definition. The beauty is that well-written fourth code can be read nearly as well as text. While fourth programming is not self-documenting, it can come close. Adding well-chosen comments bring it even closer. Here's the actual program with the D chart superimposed. We see the two loops with the if structure. I have to confess that I wrote this program in the language Octave, which is a version of MATLAB due to its portability and file conversion tools. And I had to relocate it to my son's business site. On paper, this process is beautiful. You have a question though, how can you get a running program from the D chart? And you want it immediately. So the answer, start with pseudocode as printout. Stepwise, refine the pseudocode into code, making only one change at a time. Here's the internals. You express each line of pseudocode as a print statement. In the box, the word report generates the full report. We have, and I'll read it, print the text, input CSV file, new line, print the text, set up control parameters, new line, print the text, convert all rows, new line, and finally, print the text and display. Now I point out in each of these cases, all the program is doing is printing those print strings. But now how can we make it do more? First, we add a word fake load that replaces that first string. That word fake load simply copies source code text into a text buffer, which replicates the CSV format. That is, we have an image of what one line of the CSV format looks like. We place that into a string buffer. Later on, we'll read this information from a file. At the bottom, we add a word display buffer. That word reformats the field of the text that we have in a buffer of one row into the desired left and right justified fields. Now we've covered two of the most critical elements, that is reading CSV fields and outputting the corresponding report lines. And we've done this before we get into the looping structures. It keeps the debug simple. There's a simple linear path from top to bottom. These functions are the heart of the program and should be developed in small steps. So now I read the program box, which is a define report and execute a new line, then execute the fake load. Again, print, set up control parameters. We'll handle that later. New line, execute the simple field conversion routine and display the buffer and the definition. Linear flow, no control structures. You have a shell of a program and you have enough that you could call your manager in and demonstrate and show him the progress you're making. All that remains is to read and convert the CSV file into an enlarged input buffer. Then wrap the field generation portions into the two control structures with the begin while repeat and the if else then. The good news is that we're confident of the input and output functions and only have to worry about integration with the control structures. If you make just one change or addition at a time, coupled with force interactivity, incremental compiling, and the simple stack print of .s, the pseudocode should lead directly to a final program. So we're going to summarize. Learning D-charts is like learning another programming language, only it's much, much simpler. You probably learned it here in 20 minutes, and the key concepts maybe take 3 or 4 minutes. D-charts augment writing pseudocode. Notice how I moved gracefully back and forth between the pseudocode, the D-chart, and forth. And my suggestion is to plan on using and discarding many sheets of paper before going to your computer. The design phase, I get a stack of blank sheets of paper and I write, rewrite before I go to the computer. You can capture the whole program or just a part of it on that single sheet. Okay, folks, that wraps up D-charts, resurrected from fourth dimensions of 1979. If we had brought any earlier code out, it would have had to have been written on stone tablets. Thanks for this opportunity to discuss one of my favorite technical topics. Do we have any questions or comments? Lost the cursor. There we go. Okay, you all can unmute. Any questions or comments?
Okay.
Yeah, I got my IBM flowchart maker, but I never liked flowcharts. I just like to make a lot of words until I've got the words that I need to do what it is that I want to do.
I have a template somewhere, I just don't remember where. So if I may ask, if you feel like you need to conduct your own conversation in chat that has nothing to do with the meeting or the speaker, maybe you should consider starting your own Zoom meeting offline. If this were real life, you'd be asked to just move it out into the hall.